for 11 and 12, it's giving us some information here. This is not a particularly difficult question, but I need to make sure that we understand how to approach it, right? It's asking us to find the cosecant of theta, right? So that means that's the hypotenuse over the opposite once we can find the triangle. The question is, where is the triangle, and how do I draw it in the right place to get the right signs so that I can put it down? The way that we handled this one was we said, if I can figure out the quadrant it's in, it's easy at that point, right? We know that cotangent, right here, that's a positive value, and this is saying that cosine is a negative value, less than 0. We always said all students take classes was the way we can determine where sine, cosine, and tangent were positive, right? So if we take it at first face value, the cotangent's a positive number. That means I'm in that one and this one, right? Because tangent is positive in the third and the first quadrants, just like cotangent is. So now I've narrowed it down to two choices. It's either the first quadrant or it's the second or third quadrant. The other option we have is that cosine's negative. Well, cosine is positive in the first quadrant and the fourth quadrant. So it can't be one of those two. So it would be positive here and here. You're looking for the overlapping check marks, right? Wherever you double checked, that is exactly where you should draw your triangle. That's important because when I draw the triangle in, one or both of my side lengths are possibly negative. I won't even know. Like example, for this one, it says 4/3. However, they're both negative because I'm in the third quadrant. If I hadn't really thought about that or looked at it that way, I would have missed it. So if we draw that down here, what we get is that we have, this is our adjacent over our opposite. So we're going to have a 4 and a 3. However, we know these are both negative. If you do the Pythagorean theorem, or you just recognize this is a 3, 4, 5 right triangle, I can apply that to the problem. If you go back to what we were trying to do earlier, remember we said we needed to find the cosecant of this angle. And this angle's hypotenuse over its opposite is how we're going to get that answer. So hypotenuse is 5 over the opposite of -3. And that's how you would complete a problem like this. That's it. All right? If you look at the other one, sometimes you won't see like a second thing listed, like it's just the find cosecant if cotangent is 4/3. If it's just like that, you draw it in the first quadrant, label it, no big deal, right? It's when you have this secondary information, I have to make a choice. Well, it's not even a choice. I have to find out where that triangle exists, label the sides properly just so that I can get the signs correct. Otherwise, they're probably all positive in the first quadrant, and it's not a challenging question. You've got basically right in front of you, right? Let's try number 12. Okay, so this one, cosine theta, right? I have cotangent, it's positive. I have sine, also positive. Let's be really clear. If they're both positive, it is a hands down easy, it's right in the first quadrant.
Wait, can we not do this?
I'm really not even going to think about that, right? It's first quadrant, they're both positive, so piece of cake. I'm going to draw it there, Pythagorean theorem, find out the adjacent over the hypotenuse, and we're going to get us to 12/13, right? So it's this part that I'm worried about for a lot of people. Get that down, draw the triangle in, label the sides, give it the right signs if it's negative or not. That's the one thing that you have to figure out. So we have cotangent, that's positive value, right? We have sine, it says that it's greater than 0, meaning also positive. So cotangent's positive in the first and the third, right? It's that all students take classes idea. Sine is positive in the first and the second. So I'm looking for I checked it twice. Wherever I check it twice is where I'm going to draw the triangle. I was saying earlier that if it's positive, doesn't matter which trig functions I've given you. If it's positive, that only occurs in one place. First quadrant, hands down, every time. Right? If one of them is negative, then I'm going to take my time with it, make sure I get the right triangle in the right spot. That's getting the wrong sign, and I'm going to bet that on a multiple choice test, the positive and the negative version of whatever the answer is going to be there. So it's not okay for me to just get the numbers down It'll still be 50-50, but the deal is that that's not a hard question to figure out. So don't miss this one, right? Wait till you actually get some of the hard questions. And if you're going to miss one, miss those. Don't miss the easy stuff. So we're going to look at number 23 first. And so here we have a, this is a verify an identity question, right? So that means that I have to choose a side, and I have to work on that side. I'm going to choose to work on the right side. I like it that it's cosine on the left. I like that it's tangent. I don't like to see cotangent or secant. I don't have very many formulas with those kinds of things. But if you're careful, you can already see how to get the right answer. Okay? Now be careful. Note what you're trying to get to. In this example, I have a cotangent here. That's related to tangent. I have a secant. That's related to cosine. So rather than taking my normal approach to change everything to sine and cosine, which is totally fine right now, I can kind of shortcut that by realizing that I need to go to tangent and cosine. The fact that what I've been given has a connection to those exact two things means I can go almost directly to the answer. Okay, I got to make a few steps in the middle. So let's kind of rewrite this one. What if we did this? That's 1 over tangent squared, right? Yes. Over 1 over cosine. Now, if you went to sine over cosine or cosine over sine and multiply by the reciprocal, all that other stuff, not a problem. You'll get there. I think this is a much quicker way to do it. We're going to multiply by the reciprocal, cosine over 1. Right? When you multiply it, you're going to get cosine x over tangent squared x, which is right there. Okay, next one we're going to look at is 26. With 26, what do you think would be a appropriate measure? Perfect. Let's split the fraction into the one fraction into two groups. We can do this because we see that we have two pieces on the top with a single denominator. This is only really possible with a single denominator term. If you have multiple pieces in the denominator, what we're about to do is really not something you should try because it doesn't work out very nicely. And so we're going to say cotangent over cotangent. And to be honest with you, this is exactly why I tried this. I saw that I'm going to get cotangent over cotangent. What is that equal to?
1.
And what's on the other side?
1.
I get a 1 plus a sine, right? So I'm thinking, well, this is already 1. I'm pretty sure this is going to simplify to sine. Like, it kind of has to. If it doesn't, this is false, and it's not going to work. But we know they do work. So let's keep on going. Cotangent over cotangent is 1 plus cosine over sine. And then we're going to multiply by the reciprocal here. Sine over cosine. That's cosine over 1, right? So this cancels out with that one. And I'm left with 1 plus sine x, which is equal to 1 plus sine x. What's that? Okay, the next one is 24 that's been requested. Number 24, secant times sine is equal to 1 over cotangent. Here again, there's not a lot that we have to do to make this happen. Which side do you want to work on?
The
Left side, definitely. You're going to get 1 over cosine times sine over 1, sine over cosine, right? That's equal to tangent, right? And that's equal to 1 over cotangent. For number 27, we need to come up with ways that add or subtract to get 165 degrees. Any suggestions?
You should subtract. You should subtract by 90.
Nope. So we'd say sine of, let's say, 135 plus 30. And so sine of 135 cosine of 30. When Sinbad sets the date up, he likes to sit with coset. and he says their sines are the same, right? And it's going to be cosine 135 and sine of 30. And so in order to do a question like this, I need to know the sines and the cosines of all these things. In fact, let's be really clear. The sine of 135 and the cosine of 135 is square root of 2 over 2 because that's how always the 45s work out. Just to make sure I get the right signs. But 30, sometimes we have a little bit of a... It's tricky to remember because we get them backwards. So let's draw it. Here's 30 degrees. This will be the 1. This is your square root of 3 because this is your 60-degree angle. This would be my 2. Because I'm in the first quadrant, I don't have to worry anything about my negative signs showing up. And so sine is positive in the second quadrant. Let's just draw that just to be safe. So if I'm over here, this is going to be your 45-degree reference angle for the 135 angle. This is going to be a 1. Actually, it's negative. This is a positive 1, and this is a 2. So if I needed to draw the 135 angle measure and get that, remember that 1 over root 2 is technically the sine and cosine of 135, but we like to write that rationalized like this, right? That's going to save myself a lot of trouble when you go to put this into the fractions. So what's the sine of 135? It's going to be positive square root of 2 over 2. The cosine of 30 degrees is the square root of 3 over 2.
Wait, what was that?
What was that?
The cosine of 30 degrees is the square root of 3 over 2.
Right here it is. Adjacent over hypotenuse. Right, so we can figure that out. We put it here. The next part is going to be cosine of 135. This is negative square root of 2 over 2. And then the sine of 30 is 1/2. At this point, I'm going to go ahead and multiply my fractions together. I know that I've got a common denominator overall, so I'm just going to go ahead and put that as something over 4, because 2 times 2 is 4 for both of them. That means I'm going to get square root of 6 minus the square root of 2 as the final solution here. If we look at number 28, this one is different because it has a negative 105. It's not a big deal. We've actually done one a lot like this using 105. It just wasn't negative.
135 minus 30.
It needs to be negative.
Negative 135
So
minus 30.
I'm going to do it like this. I tend to want to add to keep things simple. Negative 60 plus negative 45. Now you can add together or subtract in any way you would like. What needs to happen is that when you do combine them, you need to get, negative 105. I could say 30 minus 135, right? That would also, but I have to be careful. I'm subtracting there, and I'm subtracting 2 positive angles. Sometimes we look at subtraction and we think one of them is negative, but within the sum and difference identities, it's tricky. So I like to do it like this. If I can add 2 angles together and they're both negative, there is no doubt in my mind which formula I'm using, number 1. Number 2, what the sign of my angles are. When I throw in that subtraction, we tend to lose that, well, am I subtracting a positive number? Or is that negative attached to the second number and it's negative? There's a bit of argument there. If the second number is negative, then technically we are adding them together. And so you run into all this confusion. So it's better if you have a negative number, negative angle measure like this one, I would highly recommend that you add together two negative numbers so that you get something like this. Then there leaves no room for debate about which formula you're using, right? For example, we would say the cosine of negative 60, cosine negative 45, and because we're adding here, when Cosette sets the data up, she says their signs are opposite, so we're going to be subtracting. This would be sine of negative 60, and then sine of negative 45. And the fact that we have negative angle measures, it just means that we're going to be drawing our angles negatively, right? So that would be like negative 60 here. So square root of 3, 1, and 2. And then here would be negative 45. Remember, negative angles, just go clockwise, down around the angle. So this would be 1, 1, and square root of 2, but that one's negative. This is your 45. At that point, I'm just going to be figuring out what the sine and cosine of these values are. Cosine is positive in the fourth quadrant. So when I look at the cosine of 60, it's equal to 1/2. Cosine of negative 45, it's going to be square root of 2 over 2. The cosine of 60 and the cosine of negative 45 are, well, negative 60 and negative 45 are both in the fourth quadrant. So that means the cosines of those things are going to be positive. When I go to find the sine of these things, I know they're both going to be negative because sine is negative in the fourth quadrant. So we're still subtracting. The sine of negative 60 is going to be negative root 3 over 2. And the sine of negative 45 is negative square root of 2 over 2. So I can realize that I've got two negatives being multiplied together, and I'm subtracting. So those negatives are going to kind of cancel each other out, but I'm still going to be subtracting the entire thing. So we're going to end up with square root of 2 minus the square root of 6 all over 4. Okay, 31. Here we have, so find the length of the arc for a central angle of 30 degrees with a radius of 4. Now this one is very reminiscent of, if you go back to your first test, there was a question that might have been almost exactly the same. I think the radius was a 6, okay? But it's very similar to this. If we go back, the formula we use in this case is S equals R times theta, okay? S equals 4 times, but I can't use 30 degrees. That's, I have to convert it to radians because this formula doesn't use doesn't use degrees. So it's pi over 6. Multiply through, you're going to get 2 pi over 3. Or I would imagine if the answer is like this, you would get...
You don't even have to draw a picture?
I mean, you can.
I mean, I don't want to.
The picture is not necessary when you have all the right elements. In fact, you might be given a picture, right? You look for the radius, you look for the central angle, and it tells you what it is, right? The other way this could happen is I could give you the actual arc length and ask you for the angle or ask you for the radius. It's just going to plug it in, you're going to divide, kind of go from there. With number 32, this one is going from degrees into degrees, minutes, and seconds. So I might grab a calculator. So we're going to say it like this. First of all, we definitely have 129 degrees total. What we need to figure out is how many minutes and how many seconds are also here. We know that we're going to take that decimal 0.3321 times 60 because there are 60 minutes in 1 degree. A degree is a lot like an hour if you want to kind of think of it in terms of time. What is that product? What is that 33.21 or 0.3321 times 60?
You should get like 0.926.
19 point what?
926.
926, right? So that means I have 19 whole minutes. But to find out how many seconds, I have almost a full minute left, right? It's 92.6% of a minute left, so I've almost got 60 seconds left. But we know that each minute is comprised of 60 seconds. So we're going to take that 60. Again, we're going to multiply times whatever the decimal is left. It's going to be 0.926. What do we get here?
You get like 55.55.
55 point what?
55. So is that why you rounded up to 56?
50. Okay. So that means that at this point, we don't go any farther. We don't have anything past a second. So this is my last calculation. I'm going to round this step like I would round any whole number or any decimal number, right? If it's 0.5 and up, I round up. If it's less than 0.5, I round down. Now, I want to make a point here. If this had been 55.49, what do I do? Do I round it up or do I round down? You round down.
What?
That is not 0.5. That is less than 0.5. So you round this down. Yes, I know that if I were rounding to a tenth, 1 decimal place, I would round that to 55.5. But if I'm rounding down or rounding up to a whole number, I do not look at the 100th place. I don't round twice. If I round that to 56 from here, that would be wrong because it's not 0.5 or larger. It's 0.49. That is less than 0.5. So you round it down. Does that make sense?
Yes.
Look at when you round, you go, where am I rounding to? And then I go one place over. I don't go any farther than that. And I make that choice in there. So 55.49 would round down. Now ours rounds up clearly. So we would say it's 56. I just remember seeing this kind of thing. People would say, oh, that's 56 on one of the tests we did. And I'm like, nope, that is not 56.
5 or more, raise the score. 4 or less, let it rest.
Say it one more time.
5 or more.
5 or more, raise the score. 4 or less, let it rest. There you go. Okay, so we're going to round this one up to get our 56. And so we end up with 129 degrees, 19 minutes, and 56 seconds. Okay, 30. If we do 30, we did 29 earlier, but 30 is one of those things where I'm going to take that formula. It's the tangent of the sum of difference angles, right? So we're just going to write that out in generic form, right? You have tangent of theta minus tangent of pi divided by 1 plus, because the signs are opposite on top and bottom, then those two things multiply together. Tangent theta times tangent of pi. So really what I'd like to know is, does this all simplify to give me just tangent? Obviously it does, but I don't know how to do that. What's the tangent of pi? Right? So pi, if I look at that on the unit circle, here's tangent, or here's pi. That's the coordinate -1, 0. And we know that tangent is equal to y over x from the unit circle. So if I do that, that gives me 0 over -1. So really, tangent of pi is 0. So let's plug all that in and see what happens. We know with tangent theta, that doesn't simplify because it's just a thing. And that's minus 0 over 1 plus 0 times anything is just 0. So that really does give me tangent over 1, or just tangent, which is exactly what we'd hope to find.